Welcome to the channel. Today it will be generative design in Revit. We will start today to make a study for the tower, how we can make generative design and get the best practice for study how we can make a tower with less cost and good revenue. We will put some consideration and calculation, some regulation regarding to how to can build this tower and optimize it in generative design to get the best solution for that one. So let's start to the Revit. We have a project here and I have a plot area. This is my property line. I have like a setback 5 meter for each side. And here it will be approximately 2,300 square meter. So we'll start to make by generative design or refinery because I use here 2020. So 2020 it's called refinery and it's updated in 21-22 as a generative design. It will be shown here in Dynamo. You need to download the packages of refinery from package tool, and after start it can show here as a tool refinery. So we can start now to take the lines from Revit and make our study in Dynamo. I have here my property line and my setback. This is the important that I need to take. So let's say if I go to here element view, I show as a lines. I can now select it in Dynamo. So let's go to select. Okay, select model elements. So first selection, it will be, let's go from inside my setback. This is my model curve and another selection, it will be for my outline. Let's hide this one first. And here from selections, he show me 8 items, maybe because it's like some items down. So, okay, we can make it in another way by select elements by 4 to be more easy. And here we can select each line. And this is the detail curves, and that one also detail curves. So let's back again to be all as a one element type. This one, yeah, I will select this detail line. And then let's put this in list. So I have here the list of items and here also for this one, and then I will make it as an element and curve to show it in the Dynamo. Let's go to the element panel and element curve. Now this is element curve response. I need from element to curve. And as I can see now, he showed me my two lines. And here, like, to make sure that it's already make it by each list, so we need to flatten. So now I have my four list endpoints. And in case if I work in the refinery, you need to start to put the data. Remember, in case of any file, you will bring it from Revit, any element. If you will transfer it and put it in Dynamo, it's very important to can show it and use this calculation in refinery to put data, remember, as a gate. So, and then in this case now, we have my two lines. I think we don't need this all now. We can hide this one. And I have my main two lines now. And then we can start to make polycurve by joined curves. And I think also we can hide this one. And I have now as a full polycurve. And then we can group this one now and make it the plot line, plot and setback polylines. And this, it will be my start for the project. So now we will start to make the basement for this project, and we can add some notes and regulation that it can show me how can I make my study. And let's start to explain this, and we can add here to create a note. So I'll start to make my notes here to keep it in the Dynamo file in case of any restudy. Let's say now I have for the basement, the area for the basement should be for only car parking, and the number of the car parking who will give me the number of the units that I need in case of I need one car parking per unit. And the increase of units, of course, it will increase my revenue of this project. So let's make this calculation for the car parking. Let's say I have the size of car parking. It will be 2.5065 multiply 5.5, and this is, it will be the size of my car parking. In this case, the area, it will be for the one size of the car parking as a multiple of these two numbers. So in this case, it will be 14.6. So I need to get the area for the basement as a clear area that I can make it for the parking. And let me propose, if I have basement area for car parking, after clean all the surfaces and the wood, it will be like 30% as a clear area for this project. So in this case now let's start to make my calculation here regarding to this area. I can work as a regulation in the plot line as a pavement only if I go down. So first I will make like a surface by batch, and I can bring here this is it will be my plot line, and from the surface I can give the area. So in this case it will be my area for the surface. Also I can make as a round from the inputs from the mass, and function here you can go as a round for this number. And let's say I have only one digit for easy calculation, so 233.7, that's okay. This is it will be the area of my plot. And then let's go to make the 30% of this area. So by round, this is the clear area for one floor basement. And I will multiply in 0.3 as a 30%. So as I can see now, for each basement, when I start to make the basement to floor, I need like 690 as a calculation for this one. And then let's propose number of basements that I will do by refinery as an input. So in this case I will make as a point before we can make it point, we can create it quickly from the property line, so it's easy to make it first as a translate. Let's say translate, and translate geometry, let's say by x, y, and z, or here and direction. Okay, so we'll make it as a direction and distance to create my basement. And then I will go to the surface that I create, or we can, if I will make it as a loft, we can make it as a solid, so we can use my polyline curve that I used here. So if I go here as a small example for the basement, and let's say I will go in the direction to put it as a vector, and this is my geometry, and here let's say if I can take by 10, so it create for me in the way of the up, but in this case the basement it will be go down, so all these numbers it will be multiplied in the -1. And then let's create how can I make calculations for this basement by sequence. So to explain the sequence, let's say I have the sequence from 0 and then as a 3, and this 3 it will show me the number of the basement that I need, and after this it will be the height of this basement. So as a calculation here, I start from 0, the first location, and then I have 3 basement, and each basement has height 2 meter, and this is what I need as a translate to put the location of the basement. So as the same of this equation, we will make it now first. The 0, it will not be in this case 0 because I need my first basement, it will be in the down, so I will take it as the same number of my height. So it will be first height, and then it will be my count, the number of basement, and back again to put it. It will be count, and back again to put it as height. And then I will start to make my first 2 input that I will use it in the binary. It will be as a number slider. Let's see a number slider. And let's take here copy, and this one it will be the basement floors count, and here the height basement height. Okay, let's find my inputs. So the floor counts, it will be start from 1, not from 0, and the maximum, let's say it will be 5 basement, and of course steps it will be as a 1. And for the height, I will start my basement height, let's say from 3.5 until 5, and I can make step by 0.5. Even we need to, as a first input, 4 meter also. It can be more fine for the basement as a height after I put all the surfaces in the ceiling and something like that. But let's case in this project put it like that, and in this case I will put my basement height here, and this is my count. So in this case, as I can see now, I have only 1 basement. If I increase this number, I can see now we create the basement heights according to this one, and in this case now it will be my distance, but it's going to up. So before, same as I can see, it can be my multiply -1. I think I have here now, I don't have here -1, so let's create it. It's a -1. So I can see now you make the basement floor on this side. Let's put it here together. You can make it later as a group for the basement. And this one, because I need to collect my inputs on one side, so here it will be easy. And then let's create the solid to show it for this project as a basement. So here from easy we can make as a loft, and from loft let's say for not surface I need it solid, and let's go here to create or easy. Let's make extrude extrude here as a solid, but I need to show also directions and distance as the same. So in this case, if I create like that, he showed me now he created as a distance value 1. So I can put my input data, that will be the height, because every time when I change the height, it can change also in the calculation. And now as I can see now, I changed already this one, and let's back again. If I start to make my calculation, placement can be reduced, and in the same time, if I need to increase my height, I can increase it in this way. So let's put as a 4 now and 2, and we can also make by color. It can be more easy to see. Let's try the color palette and geometry color. So I have this one, and let's say put any color as a blue, and in advance I need a little bit transparent. Put it like that, and then we can hide this too. And in this case, clearly I can see now my basement floor. Even we can keep this one to see the lines. Okay, that's cool. In this case also, I don't need to show this one. So now I create the basement regarding to the two inputs that I use it, and the inputs is the height and count, and then my count here regarding to this calculation, it's related to one basement. So I need also the connection in case of I need to increase the basement, increase the number of the area that I needed, and at the final I can show the number of the parking for each basement. So in this case, I will multiply the clear area for one basement in my input of the basement floor count to get the clear area for the full basements that I have. So let's make another multiply, and I will say here I need the total area for parking and basement. And I will get this number that I have it here, multiply in the basement floor count. And after that, I will make the area for the, or not the area now, I need to calculate the number of the car parking that I need here. So in this case now it will be as a divide, not multiply. So let's delete this one, and let's go to the operation, and it will be, I will divide the total area in the area that I already put it 14.6. So as I can put it now 14.6. And as I can see now in this case, I need like, let's make round, I don't need it by digits, I need it by integer number quickly. So here I need like 142 total number of car parking, and also it will be total number of units. Because I can add also here as a note for me, like each unit needs one car park. And this, it will be one of my outputs for the project, the total number of the car parking. We will finalize the input and outputs in the end. So now I can select all of this and create as a group. And let's say this is my basement calculation. Can add also the same color and what we did in the geometry color. So now we finalize the basement calculation and how the area that I needed for the car parking, that I will use it as a study for the project in the tower. The second things that I need to use it here, it will be how I can make my podiums and I can make my towers. So in this case, can make it more easy if we will not use the podiums of this project, or we can add like maximum 1 or 2 floors. But in this case, I will use only the tower as a calculation and as a unit direct in the study. So in this case, I have this is my setback, and this time I need to not exceed this setback in my design. So as I can see here, I can choose first to make a surface and the center point by U and V in this setback limit. So I have here patch, and from the patch I will get a surface, and from surface I need to make point at parameter and surface. Let's use it twice. And then point as a parameter, I will use a midpoint, so it will be 0.5. The parameter U and V, it's between 0 and 1. So 0.5, it will give me the midway in the vertical and the horizontal shape, and I will connect this surface, and in this case I will go here to get my polycurve to create my surface. So as I can see now, I have my surface and I have my center point as a parameter here that I will create my tower regarding to it. So in this case then I can make my tower on this side. That's also a little bit thinking, maybe it's if I can add the podiums, because I want to cover like a full study in this project. So okay, we can make podium and then we can make tower. So let's say in this case I will create the podiums here. So I can use first my length and width for this setback area. It can be more easy if I bring it from the Revit. So if I back here, let's back again, reset this one, no problem, save the project, and let's quickly see. In this case I have like 60 and 29. So So let's put it here as a number for now, 60 and 29. So in this case, I will create a rectangle, and the rectangle should not exceed the length at 60 and in the width at 29. So I will create it as a number slider and then connect it to these points that I created, so I can make for now the plan. I need to create plan by points, so yeah. And my normal, it will be also Z. So in this case, I will connect this one and that one here. I think we need to back from Revit, yeah, to show this one, okay. And then rectangle, it will be by plane and width and length. Yes, that's what I need. So I will put my plane and width and length I can make as a number slider. Copy. And in this case, it will be my width and here my length. Let's add here to the podium length, and here it will be my podium width. Connect in this two line. Let's say I don't need to reduce the size of this one because it will affect my tower after. So let's say the maximum here in the width, of course, it will be 29. I can go by 1, and let's say 20, it will be my minimum. And I think in this case he got it to this way, so we need to change this one. Okay, let's go that one here and go this one here. Okay, and my length also, it will be the maximum 60 and the minimum I would say like a 50, and also step by 1. So this is my area for the podium. I can, if it will increase in my study, it will not exceed 60, and as the same, it will here not exceed 29. And also it will be another input for my study, and this now it will be my rectangle. And as the same, what I did here for this study regarding to the geometry, translate, multiply number, create my solid, and put the colors, so I can select all of this again. Let's get a copy here. Okay, and let's remove my connection and check what actually I will do here. So I have now also the height and the count for my podiums. So in this case, I will create two inputs, and this it will be my podium height, and this it will be my podium counts, and height here between 3.5 and 5. Let's try to make this from 4 until 6. The podiums like need to be more 1, and here between 1 and 5 as a maximum. In this case, I think 3 will be as enough as a proposal in the calculation. If you need to increase the number to see the more optimization for the refinery and how it can affect you in case of you will use the podium as a rent area, and it can give you more revenue. But in this case, I will make it as this number for this study. So I have the same now. I have my podium height. I think I connected to the height. Yes, right. And I have my count. And then I think in this case, I don't need to multiply by 1 because I will go up. Now, direction, I can use also the same. And this is my rectangle that I already used, so I can use like that. And let's remove this one and connect directly here. So he creates for me now. Let's delete this one. And as per calculation, let's say this, make it okay, red color, and okay. So if I look here, it's nice, but I see like there's a one floor already not there. The problem is I here used my height in this calculation because I go down. So my first height I needed to start down, but in this case my height I need to start from 0 because I need to count also the ground floor. So in this case I will just change only this one to 0. So now I can see clearly if I have 3 podium floor counts and I have podium height. As I can see now, this one is increased, but I think I have a small problem here regarding to the height. You not follow the distance, yeah, because I didn't connect the distance in this one, so the distance here should be connected with the height. So let's go here and go to take the height, use the old distance for the basement. Yeah, let's go. So now I have my podium in the calculation, and at the end I have my podium floor area. Let's put this one all here now. And as I can see now, that's my podium. And in this case also I don't need this one. Let's hide it, and this one into my other group. And the podium calculation. And let's save in case of any crash. Okay, so we finished now the podium calculation. We need now to start to make the tower calculation. And in case of the tower now, I need to start from this floor until to go to my floors of the tower. So if I need to start the tower from this floor, I need to check and take the reference of my height of this podium. If you back again to this one, as I can see now, it's 12. This is the highest point of the floors, so I need to take always this number. To get always this number, we can also get the height per count as a calculation, because I will use it also in the calculation of the total height of this building. So let's say here, if I make this calculation quickly to get the height of that one, let's say x, or make it by calculation, it's more easy and finite, because sometimes he not accept this one. So from here I will make my height as a 18 for the 3 floors. Let's reduce a little bit the height until 4 or 450, that's okay. And let's call this total height of podium. Okay, bring it here to start to do my tower, and I have also my rectangle that I use it as a reference. So I will use the same point that I use it for the project to not to extrude the length and the width of this tower. In this case, I will make first surface by batch. I will take this one. Okay, I can take also point at boundary and normal at point, and this one, so I can copy this here. Can you copy for me? Oh no, I don't need this one. So okay, let's make it more easy. On the floor I have this rectangle, and we show here the lists and width and height. I think it should be the width and length, but in any case I will use this two numbers as a value. So in case of I need to get the width and height, so I will get that two, and this is always as a double for the number for me. Now I will make my tower here after I get my rectangle width and height and the total height to translate my tower to start here. In this case, first I will get the copy of same of what we did in that one. So I need here the rectangle of the podium that I already used, and from this rectangle I will get also surface by patch, and I will use the same what I did here to get again the rectangle of my tower. So let's copy this one. I think now I don't need these numbers, and in this case I will see from now this rectangle I will connect, and from this one I will connect it here. I have my connection point, and in this case now I will remove this two. So as I can see, if I put these two values, it create for me exactly the same of my podium area. But in this case, the tower, it need to be smaller. So I need to create as a optimization points or optimization ratio to can affect with me in the calculation of the tower in case of I will calculate the total built-up area. And also in the number slider, I cannot put as an input because I already don't want to exceed the tower, the width and length of the podium to be logic. So I will use my number slider as a ratio from 0 to 1, like from 10% until like 100%, and multiply and the width and height to be my inputs for my calculation in this project. So I will say here, I will start from point 1 until 1, and I will go point 1. And this, in this case, okay, I think we don't need now to rename it. And in this case, I will multiply let's say this is exact, so I will connect the up one with up one, so I multiply this one with that one and connect it here, the same. I will do this one and connect it here. So in this case I have no changes, but if I change now this one, as I can see, I have an issue here. Even I can move it up in the exact location, it can easy to explain the point and translate it. So let's say first I will translate. I will translate by also z, and this one, let's get any z vectors or create it especially for this group. Okay, no problem. And the distance, it will be the total height of the podium. So in this case, my tower is here now. And I think I don't want to see that. This is my start point of the tower plan, and in this point, as I can see here, it will be my tower issue that I can calculate it by Dynamo, and I get here, let's say, tower plan ratio x, and in this one it will be y. And now we will do the same process that we did. Let's propose here in the numbers, so let's say 0.5 and 0.5 or 0.7, anyway, just to show the calculation how it will be. And I will do the same extrusion. I think I will take also 1, 2, 3, 4, 5, create copy. I need to count and height also, that I will use it for the tower in this case. So let's disconnect this one. This will be my geometry translate direction as the same in Z, but I can use it here for this group. And this one, okay, also just change the color. Let's say it will be green. In this case. So now I need to create the same. And now this is, it will be my tower height and tower flows count. Tower height in this point, I will say like minimum 315 and maximum, let's say 3.8, and let's go 0.2 in my calculation. And in the tower flow counts, it will be minimum 1 and maximum, you can say 30 or 35 as a count. it will control later when we calculate it in the built-up area. And here I will put my height and put my count. And in this case, maybe I can increase. No, I think I might put it in the wrong way. Let's put it in here. Yeah, I put count instead of height and height instead of count. So in this case, it's right, and if I need to increase the height, so this is perfect in this way now. And this is, it will be my input for my tower and my final shape of the tower. As I can see here, if I zoom out, take a little bit look. Perfect. And group this one, it will be tower calculation. So now I finalize the 3 calculation that I will use it in the final for this tower to calculate what I need. The next step, it will be how to calculate the cost and the revenue, how I can put constraints for the height, constraints for the built-up area, and to get the best result for this one. And also we can just like make sure all our calculations and the study in the right way, nothing in fault. So my basement height, if I change it in the good way, increase it in the good way. Also now my podium width and length and my podium account, if I go down, I can see now it's already going down, and the tower, it's already in the perfect location because I already make the connections between the tower and between the total height. Also the same here, if I change the podium height, it will go in the correct way. The ratio, let's work in the good way. Even if I change the width and length, it will be the ratio. See how can the ratio between the podium and towers, it's go in the perfect way. And in the any case of the another input that I will increase the ratio for x and y for the tower, it will be useful for me to calculate the total built-up area. And as the same, the tower height, if I will reduce it and if I increase also the count, if I want to get my maximum number of this one. And in this case, we finish the first part, that how we can make first the calculations to create the 3 main points of my tower. And then in the part 2, I will start how to put the cost, how we can put the revenue, how we calculate area as a ratio for the units, and affect me in my revenue as a count and numbers in the car parking. What's the best solution that it can give me by generative design. We can continue in the notes that we already start worked in here, and let's get it. As we can see, for all the nodes for the basement, like the size of car parking and the area, and for each unit I need one each car parking. And regarding to the area, we can know the total number of car parking, and this show me the total number of units also, but I can get it when adding all the parking area and the basement. So let's create also another node to continue my calculation here. So just create another node, and in this node we will say, as per regulation, I have like FAR, let's say 10 times, or maybe like more than in some ratio as a 100%, but in any case it's like 10 times the area of the plot. So let's say the built-up area in this case, it will be, if we say like approximately 2300, this is the plot area of the project. So let's say it will be 23,000 meters square. I cannot exceed this built-up area, and this is one of the constraints that I will use it in the project. Also, I have here the height should not exceed, let's say in this project, 130 meter as a full height from the ground floor level. And all these constraints, it will be useful for me to optimize the best solution in the generative design or done in the refinery. And I will say now for the unit area, it will be 80 meters square as an area for the example 2-bedroom as a clear. And in this case, I need to say like in tower, I have surfaces area in floor approximately like a 30%, including all the corridors, all the surfaces, left stairs. So the clear area for rent, that will be to 70%, and from this percentage I can get now the total number of the units per floor. And now let's calculate the area for each type. If you have the basement, I have the podium, and then I have the tower. So very easy here to have first one by one. Let's take first to the basement. The area, of course, it will be the area of the plot multiply of the number of that one. So I can see here, this is the total area of basement. And let's make here also 3 copies for the podium and also for the tower. And it's easy to make sure, okay, this polycurve first need surface by patch, and then I make area, and it will multiply in the number of the basement, and here it will be podium, and here for the tower. Copy this also. And then we can go to connect this one. And in this case now I have the area, but he didn't calculate it. Yeah, I make it as a one. Okay, let's connect all, and then we can consider area for each one. Here also I have, no, this is the translated one. I have here the area for the podium, and also it will connect it here. And the last one I have the area of the basement to make sure, yeah, it's that one connected here, and it will be multiplied in the count of each floor type. So in the basement, I will multiply in the count. Also here in the podium. And for the tower. And from this one, I will make as a list to get this tree value. And from the list, I will make like summation for this value to see my built-up area. Now click on, and as I can see now, he gave me my built-up area. In this case, to be more easy also for the calculation, I will make as bound, and let's say this is total built-up area. In some cases, they calculate with the basement as a total with substructure or without substructure. So in this case, we can, as example, put it with a substructure and get it the total built-up area. So in this case, it will be like 26.135, and as you can see here now, as the regulation is already exceed, and this is what we will know how we can generate and optimize to get the best solution. So this is, it will be the first thing, and I will make it as a group and as an area. And this, it will be one of my outputs. The other outputs, it will be the cost of this project, and the cost of this project, it will be related to the square meter and to the also built up area for this one, but it will different regarding to the each floor. So let's say I have for the tower, it will be like $1,000, and for the podium, it can be a little bit 1,020 per square meter and 1,500, and we can add here the note for the let's see edit. And this, it will be the cost by dollar per square meter. So to get the total cost in this case, I will also take a copy of this 3 items, and as the same, I can take copy also. Let's take copy also from that one. And then in this case, I will the surface for that one as a total. In case of total, because now here he give me in case of this one, no, in this case I need to bring the total area for each floor type. So let's say here this, it will be the total cost. And in case of the total cost, I will connect this one here and the podium here and the tower here, and from this one I get the total area of the basement multiplied in this number, as the same here for the podium and here for the tower, and then I can connect these 3 points, and let's run. And here he can give me now by dollar what the cost of the project, like 3-4 numbers here, 28,959,047 million, and in this case it will be cost, and this my total cost. And then I will try to give an example for the revenue that I can get it regarding to the like monthly rent or yearly rent for the apartments, and how it can bring for me as a revenue. So in this case, I need to calculate how many apartments I can get regarding to the parking and regarding to the unit area here, because I have like 80 square meter, and it can be comply what's the best solution between the area and between the number of the parking. So let's say I will make note as an apartment year rent. Let's say if it's approximately $2,000, for example, 1,500 or $2,000 multiplied by 12. So in this case, it will be 24,300 per month. And in this case, I will bring the area and how many car parking that I can get it. So in this case, I will do as a small equation. It will be 70% of the clear area that I can rent it from these floors. So I have the total area of the tower, and in this total area of the tower, it will be multiplied first by 70%, and after this I can divide it on the 80 square meter to give me around how many apartments that I can have as per these floors. So in this case it will be this area divided on 80 square meter. In case of the calculation, it will not be a big deal to make it as a one, and I have here 165.52, so of course I need to make like round. And here it will be total number of units as 166, and from total number of units I will calculate my total revenue. It will be 24,000, and in this case I can get my total revenue here, and this will be total revenue. And now I finalize, calculate the area, calculate the cost, and calculate my revenue. And also you can add a small equation as an operation, and to get, for example, the net profit, we can add it also in our equation as in the simple way. So we can say also I have like a cost on 10 years. So my total cost, it will divide it by 10 years, and I have my operation. And let's say it will be like $2,000 per year for each unit. And I have also my net profit, like it will be revenue minus operation minus 1 year cost. So we can do it in the simple way. In this case, I will have like total operation and this it will be total operation per year, and I will say it will be as we said $2,000, and I can multiply by total number of units that I have it here. And then I will say cost per year, it will be divided by 10 years. You can put in here as a question. And I can get my total cost. And then in this case, I will bring my net profit. So net profit will be cost now let's say revenue minus cost minus revenue minus cost minus operation. So this is it will my cost per year. This is it will be my total revenue that I get it per year, and this it will be my operation. This is the cost per year, and this will be my operation. And then he give me my net profit. I think it can put this as output. So now let's say to make it as an equation, because the custom nodes it's not show like that. So I think if you make as watch, if I make watch, I think the watch can be output. Yeah, so it's okay. So I can just put it like that, and I make this my net profit. And this it will be my output. Create as a group, and this is the net profit. So I think now all the complete data, as a small example, it's here. Of course, like too much calculation, maybe add later as a real estate or any hotel value issue. to exchange the operation, incrementals, the number and percentage of the usage and rent of the units. We here to give it as example and put it like 100% as rent per year for each unit, but it's just to help us in our calculation and design for this tower as an example. So let's now start to make our inputs and our outputs to can show it in the generative design. So in this case, of course, I will add the basement height, all this data. It will be now as an input. And also we can now check our outputs. So our outputs as the beginning, it will be the total number of units and the total number of car parking. So in this case, I need to check the total number of my car parking as an output, and also I need to in this case I just need only the car parking, and from here I need to put as my total POA as output, total cost, total revenue, and my net profit. And also I add the total number of units as an output. And this is all the inputs and output that I can start to optimize it in my generative design and see how it will affect in my project. So in this case we can go now, let's save first, and then we can go to the refinery. And let's make new study. In this case he showed to me now inputs, output setting, and issues. And issues here, he just only, I think we don't have any issues, just the only issue that we will have it's to, he need to run the server, and now it's running. Okay, now this is all my inputs: basement floor count, basement height, podium width and length, and then podium floor count, height, tower plan ratio, tower height, all my inputs, and this is all my outputs. So in this case, it's not a big, so I cannot read it. So I will try here to total number. I think this is the total number of car parking, so I need to maximize it, of course. Total BOA I need to maximize. Total cost I need to reduce, so minimize. Total number of, and this is total revenue, of course I need to maximize, and net profit I need to maximize. And I think this is the total number of units also I need to maximize. So in this case I will try in my optimization to reduce the cost with increasing of all the items that I want. And here this is the setting for the calculation size. Let's start to increase the generation and seeds for this one. So let's say this 100, this 100, and let's say this is 8 seeds, and let's start to be like optimize and see. So it will take a time for the calculation. We'll be back to you when it's finished. And as we can see now, while calculation, he starts to process and give for me to optimize solution regarding my inputs and outputs. Also, you can show it as a table. As I can see also all the proposals that he starts to create it for the proposals. And later I can use my filter once it's finished the calculation to get the best solution according to what I need. Okay, now so the calculation is finished, and as I can see now, he can give me all my seeds and all my proposal down, and also he can give it to me here as a table. And also one of the easy things, okay, let's show the parallel coordinates, and by filter it will be more easy for me to can select what I need in the area exactly. So for example, let's say we can study this, and let's say I will mine my maximum net profit, and in the same area my total built up area as a regulation as what we put it like here as a 20. If I come back again to my design and say like 23, so in this proposal let's try to check here to not to be maximum 23 as a proposal. So in this case it will not affect for the profit that I want, so I can see now from the area of the built up when it increase until 23 or 24, like what I see here. This is the area that I can play as a profit. So in this case, we can, let's say I need all the maximum in this area that I can get it. And let's say all this also studies, but in this case, I think I need my maximum built up area. So of course, all it will be maximum 20 will play in this area and 23. And then let's say I need to reduce my basement. I don't want to build too much basement because it will cost me, but in the same time, this is the useful to have to see total number of car parking and total number of units that I can check between how he can provide for me what I need. So the total number of units here, let's say in this study, this is my net profit, this is the total number of units, and I can see here the total number of the car parking. So in this case, I need to get to the almost ratio if we will say the same concept of like each car parking need as a 1 unit. And in this case also, I can go to the total number of car parking. And let's say I need my maximum study in this one. And as I can see, as the total number of car parking, he only lead me to the 5 basement. And the maximum number here, he show me like 273. So if I go to my total number of units and I see how it's give me as a count. So in case of the big type of car parking number, he can give me the total number of units as a 1, 2. So in this case, I can reduce my study in this case to get the value that I need in case of if I reduce a little bit the total number of car parking, because I need to reach to be almost the same number. So let's say here 180. Also, I can reduce this one, or in case of I need to increase this number as a 5 parkings. But let's give as an example in this area and increase a little bit in case of I will reduce this total built up area. Maybe I don't need to build all this building. So in this case, I will go in that way. So as I can see, by the total number of car parking, I can get this total number of units. And also, let's say if we will increase the built up area a little bit regarding to the what we need for the project, let's say a 3 or something. So now I can reach to the almost the same number in case of 3 car parking, and for me as a study, it's okay. Also, once we can see here, in this case, I can reduce all this until to get my best profit, of course, after zero. Of course, I don't want to lose. So I can control in this way for that one. And as I can see here, the total number of units and total number of car parking. If I reduce a little bit, it will already reduce for me my net profit. And he showed to me the total cost that already I have to spend here. Total cost also, it can control regarding what the calculation that I did. So in this case, we can manipulate by all these numbers. Even later, we can also, regarding to the height of each floor, I can add the volume for the price of the floor. You can give you also the value in case of the height. It will affect me for the number of floors and also for the height of the total building, same as what we did here, but we didn't add it to the calculation because we don't need to put too much calculation. But I can also, maybe in the later study as a generative design, we can consider the height, and we can consider what I can do by this height of the floors regarding to the total height of the building. So I hope that can be useful for as a small example of the normal study of the building. Even here I can use all the calculation that I need to get all the ratio, to get all how the cost that I will pay, the operation, and the number of the car parking, total built up area that I will don't need to exceed it. So let's say if I will do it from the smallest to the biggest, so here 34, if I reduce a little bit the number from this area, the first start number that it can show to me, it's 24. So in this case I can, if I get more down for the total number of car parking, if I need to increase this one, so in this case I need to go the 4 and as the same for each step. Once we finish this one, he will give me all the options that I have here, all what I can do. For example, I need to do for what the best net profit for me. This is the best net profit that I can get it from this study, and I have like 142 car parking, I have 3 floors, I have 148 units, and the total built up area is a little bit high, but it will not affect regarding to the study and the regulation. So maybe it will be the best option. And when I select the best option, I will see it's already direct in the Dynamo start to manipulate this one. And more advanced, like what we say, we can add it as a height. We can add what the revenue maybe I needed from the podium in case of some shops or rentals. But as a simple, I hope that can be as a simple study useful. I will put these files regarding to the Dynamo in the link down, so you can download it and you can be useful as a simple study. I used already as a Revit 2020. Don't forget to subscribe us to our channel, and I hope that can be useful for you, and see you in the next video.